Let's start with the problem of face detection. We're going to take advantage of Mathematica's ability to recognize human faces in images and to identify those parts of an image which contain faces. I'm going to be working with a 1945 photograph that comes from the Truman Presidential Library. So I'm going to import a copy of that photograph from the Internet Archive where I archived it. There's a link, hyperlink to the original source if you want to go there and check that out. And then we'll show the image. So here's the image, the photograph. It's a picture of Truman with Stalin and Attlee and some other men. Now the image itself has not been resized. I'm just displaying it with image size large here. We can find the dimensions using the image dimensions command that tells us that 651 pixels wide by 485 pixels high. If we use the find faces command and give it the image property like we're doing here, it will give us a list of the faces that it's extracted from that image. So if we look at the original image, we see that there are 7 men there, and it has extracted each of their faces and gives us this list of thumbnails. Now, the default output of the find faces command is this list of rectangles that locate each of the faces in terms of the pixel coordinates. So instead of actually giving us the images, the default output is just to give us the little rectangles where each face can be found. And it looks like that. So these are the pixel coordinates. You'll notice that they actually have a fractional part, so it very precisely locates the corners, 2 of the corners of a rectangle, showing us where that picture can be extracted from. Now we can use this rectangle information with another command called highlight image. So I'm giving it the photo and this list of rectangles, and it shows us when we plot the image, we can see where each of these men's faces was extracted from. One of the things we can do with this is if we wanted it to take a slightly larger region around that, we could get a portrait style clip. If you look at this list of faces back here, you'll see it's focused quite in on the face, the part that's been detected, but if we wanted a portrait of the person, we could expand out put an offset around the outside edges of that, or some padding around the outside edges of that image to create like a portrait image of them. Now there's a command called facial features, and this is quite high level. It's using machine learning, but what it attempts to do is it attempts to identify age, gender, and emotional state of each person, and we can do it on the data set of the facial features. So here's the image, here's the estimated age, gender, and the estimated emotion. Well, it's hard to tell if those people were angry or sad or neutral, so I'm going to set aside the emotion for a moment. Obviously, it got the gender correct. We can ask, and in fact we can use computable knowledge to figure out whether it got the age estimates right. We've got their birth years in a list of rules, and if I use the map command, I can subtract the date when the photo was taken from their birth years to get their actual ages. So here's the ages at the time, their actual ages at the time the photograph was taken. If we compare this with the ages that were estimated, we get the difference, and in fact we can find that the estimates are, the median estimate is about a decade too young. So Mathematica thinks that these people are in their 40s and 50s, and mostly they're in their 60s and 70s. There's another function in Mathematica in which we can use machine learning to attempt to identify which notable person is in a photograph. And I've wrapped this up in a little function here, which I'm calling notable identify. We can pull Stalin's photo out of that Potsdam photo, the photo that we're working with, and then we can use this to try to figure out which notable person he is. And in fact, he is one of the 3 choices, but Mathematica doesn't assign a very high probability, and in fact it's not Mathematica's first choice as to who that's a picture of. It doesn't assign a very confident interpretation there. It's much better at identifying people from the more recent past. So for example, if we take a picture of Margaret Thatcher, it's 85% sure that is Margaret Thatcher, and then pretty unsure that it might be a famous actress. If we do the same for Hillary Clinton, again, 85% sure it's Hillary Clinton, and again, pretty unsure that it might be a famous actress. Another thing that we can do while we're exploring identifying people and dealing with historical photographs of people, another thing we can do is we can use Mathematica, image processing and computer vision, to investigate historical photography. So what I'm doing here is I'm loading another image of Stalin, and again I have archived a copy on the Internet Archive so that it doesn't go away if the original is removed. I'm going to import that image, and then I'm just going to show it with a frame around it. So this is a dual image, and it shows Stalin with a commissar, this fellow here. When this person fell out of political favor, he was removed not only in person but from the photograph as well. So this is an example of a doctored image. The image has been doctored to remove a person for political reasons. Now, we can compare both of these photographs, but since they are currently combined in a single image, the first thing we have to do is we have to clip out the two images. And we want to clip out portions that correspond to one another. So I'm visualizing the part that we're going to clip out with the highlight image command and the pixel coordinate rectangles for the picture on the left and the picture on the right. And when we crop these images, we end up with before and after images that we can compare to one another. Now we need to compare the image dimensions to make sure that they're the same. They are the same. And now we can use a command called image difference, which allows us to tell where two photographs differ from one another and where they're the same. And one of the things we see immediately is this kind of ghost-like image where the commissar has been removed. But I want to direct your attention to something else about this, which says a lot about Stalin's regime, and that is that not only has this fellow been removed when he fell out of political favor, but if you look at Stalin himself, you'll notice that he's lost quite a bit of weight when the image was doctored there, no doubt by someone who knew that it would be prudent to do that.